Yo. Okay, so we're in the process of implementing, or together with Unity Graph Toolkit, we're trying to implement a visual way to define how creatures looks. Pretty much. We have the graphical side of things, thanks to Unity Graph Toolkit. But we also have the runtime side of things, already implemented previously, because we defined our creatures like this previously. So the idea is to instead of defining a creature visuals like this, we define it like this. But we're pretty much just halfway there, I reckon. So I didn't stream yesterday, so we're gonna start today by reviewing what we did this Monday, and then we're gonna commit it, and then we're gonna continue. If I recall correctly, we should continue with implementing the converter, so something that exports the editor graph to a runtime graph. But okay, we did a few big changes this Monday. I think the biggest change was, the implementation of generation runtime node. Because if I remember correctly, it was pretty much just empty previously. And the removal of node rules. And all of this could only be done thanks to the introduction of like generic struct, generic type like this. And yeah, I'm not entirely sure I like it a lot, but I'm not sure if I love it, because we have a lot of casting back and forth within the methods. But I guess that's okay. What this helps with is that every node is pretty anonymous, seen from the outside. So we can ask it for stuff and get that stuff if it's possible. We can ask any node for anything, but it will only return it if it's possible. I think the important part is that we can ask any node for anything. So pretty much we have is start node. It's just if it doesn't have any inputs, it's a start node. And this, we only have this method because I think it would be smarter to, so when we convert this one to a runtime node, we start with the nodes that doesn't have or rather when we'll see. It's good to have it. We have add input node, and we don't have any class that represents a connection. Instead, when we add an input, we just add the input node. Yo, what's up, Derek? Link is just if we want to, we add this one as an input for this node. Do we want to add this node as an output to this one, pretty much. Add output, and then we also have try get output, so it's very nice. We can ask a node try get output mesh, and it will return it if it can, otherwise it will be null. We can do try and get input as well. We have a static method here just for linking. Don't know if we're going to use it. But then we have is compatible with input, is compatible with output, can input, can output. And then we have the biggest method where most of the logic goes, which is generate output. So we can take set mesh runtime node. This one takes input game object and mesh. So when we want to generate an output here, the first thing we need to do is to try and get those inputs right. So then we do try get input. And here we just loop through every node and take the first one. Although, here's one problem. Current implementation leads to problem when we have two inputs of the same type. But it will work for now. But yes, we try and get those. So from any input, get game object. From any input, get mesh input. If we can't get it from any of these, we return false. And then we know that this one will return an output of game object, of type game object. So we just set it here already. But then we actually do what this node is supposed to do, i.e. take this one and apply this mesh. So we try and get skin mesh renderer. If we can, we set it. If not, we try mesh filter. And last resort, we add a mesh filter. And we have something similar here. Instead of mesh, it's a material we add. But here we also... we don't instantiate it. Then we have a couple of instantiator nodes. Generate output. Here we just instantiate material. Return it. Game object, here we instantiate a prefab, but if the prefab doesn't exist, or is not set, then we just instantiate an empty game object. Then we have dynamic mesh generator, which given some setup generates a mesh, a dynamic mesh, not a Unity engine mesh, but a dynamic mesh, a much more detailed and parsable type of a mesh, pretty much. It's not, this one is not supposed to be rendered, it's supposed to be parsable and in an easy way. Implemented it a couple of weeks back. Then we have a couple of converter nodes, inputs a game object and creature. I'm not too sure about this. Eventually we probably want to do it like that, but initially we just want to add the creature like this. So we're going to remove this one. So inputs a game object, adds a creature component to it, and returns the creature component. And then we have dynamic mesh to mesh runtime. This one takes a dynamic mesh as input and calls get mesh method on it. And we have tested it here, these nodes, so we know that it works. I think we're gonna commit, yeah, we're gonna commit everything here except for this one, so that's in runtime. And let's see here, generation strings, editor graph. What have we done here? Yeah, this is the exporter. We're not going to commit this one either. We're going to skip. Oh, beautiful. Yeah, we're going to commit all of this. Generation editor node. Yeah, this one we haven't implemented yet. Let's see. Okay, so we're just going to commit everything in runtime except for this one. So just give me a sec. It's this one here. Remove, implement first iteration. Yeah, this one is done now. Although yeah. It's not done. Like, this runtime node graph is going to be represented as a scriptable object, so we don't want to do any changes to a scriptable object at runtime, right? It's going to describe our graph, but then when we want to run the graph, we're going to have to instantiate something that keeps the state of the graph. We don't want to change anything with the scriptable object, but we also want to be able to cache stuff and things like that. So yeah, that's going to be the next biggest problem. But okay, I want to add a task here. Rework using generic type. Yeah, let's just put it like that. Yeah, it's much better, but I also want to remove. So now I added everything. I want to remove this one as well. Don't want to commit it just yet. Which one was it? Creature generation runtime graph. Okay. Okay, that's about it. A nice little review of what we did and how everything works now. So now we can finally continue with this one. So creature generation editor graph exporter. The idea is that every time we make a change to our creature graph, any creature graph, this one will run. We will get the graph, and then we're going to convert it to a runtime graph. So we fetch the creature generation editor graph, and we basically want to output a creature generation runtime graph. Okay, what do we have so far? We have a queue, unvisited editor nodes, and we get an end node. So this was the initial idea. Maybe we can still run with it though. Let's see. So the idea is that we get this one and then we go backwards. So we get this one, then we get this one. But here we have two inputs. So we start with this one. That's a leaf node. So we add that one. Then we go to this one, add it. This one, add. This one, add. And we need to check if, unvisited. Here we have dictionary generation to runtime nodes. So the idea is we also want to make sure that if we have something like okay. If we were to have something like this, we have to make sure when we generate it that this one's input is the same runtime node as this one's input, because we have one node here outputs to two separate nodes. Very important. Like this example doesn't make any sense. Like having two set mesh editor nodes like this, but it's just to show that like when a node output branch to separate nodes, like if we walk backwards here, when we convert it to a runtime graph, we're going to get to this one at two separate occasions. It's very important that we just instantiate one runtime version of this one. And that's what generation to runtime nodes are going to help us with. Okay, so yeah, this one, we're going to take the end node, which currently is, let me add a note here. So what we do here is we get the quote-unquote end node, we add it to our queue, we create a dictionary as well. And while unvisited editor nodes has any nodes, we fetch the first one, and then we check if generation to runtime nodes already contains this one, then we just continue, because that means that we have already parsed it pretty much. We have already created it and added its inputs to unvisited editor nodes. So I had this idea here that we were gonna do, and I think I still want to do it actually. If we take a look at generation editor node, abstract class doesn't really do that much right now, but I have something like this: generation runtime node to runtime node. I think this, like, it would be so cool if we could just get the node, call this one, and add it. Yeah, I'm pretty fucking sure this is what we want to do. I would like to have a couple of other methods here as well. I think I would like to have get inputs, but I want to get the inputs as generation editor node, because if so, like what I want to do here eventually is so we do generation, I want to do something like this: generation runtime node, but we're going to rename this one to editor node. So generation runtime node is equal to editor node to runtime node, just like that. And then we do for each editor, or what is it? Generation editor node input editor node in editor node get input nodes. Here I want to do if, yeah, we pretty much want to do the exact same thing here. I think. So we get all the input nodes and then we loop through them, and if, I guess we can do this, if it doesn't contain it, input editor node here, then we do Yo, up Valley, why you're writing inside of comments, because we don't have, I don't have, this method isn't implemented yet. Yeah, a few of these aren't implemented yet, so we would get a lot of errors here. I don't want to get those errors just yet. And the idea was initially that it was going to be a little bit more of a, not proper programming, but a little bit more like sketching, or whatever it's called. But let's see here. Yeah, and here we just want to add this one, I guess, but no. We want to add it to yes, but the arrows could help remind you of what needs to be done. Yeah, but unfortunately, if I switch back to the editor and we have compiler errors, we're not going to have, like, stuff is not going to update as it should here. We're working with the editor tool here, so I want to get it. I want it to update between iterations. I think the only thing we're going to do here is enqueue input editor node. We're going to check this later on, but I notice now that we already have an issue here. System collections generic. What kind of issue is it? Dictionary contain. Isn't it contains? It's 100% contains. I have a problem here with my editor files as well. My IDE doesn't help me as much as I would want to. We get the wrong highlights and stuff like that. I haven't had the time to fix that. So we have a lot of things working against us here. Dictionary node, generation runtime node. Yeah, I'm pretty sure we want this one to be editor node as well, right? But not that one. Yeah, this one we're gonna do as well. But okay, let's start with node here. What? Do we get dictionary from something else? Is that true? Hash set. Ooh. Okay, that's hash set. I want to see. Don't we have diction? Yeah, we have. Contains key. Okay, that's why. Contains key editor node. Value what does generation in generation runtime node. We're gonna generate creatures using a graph like this. And so generation referred to like creature generation. Okay, there we go. Value my typing's awful today. Same here actually. So I guess the name only makes sense, or the name makes the most sense when you get it. I think it doesn't make that much sense, but generation here refers to creature generation. And we can clean it up. Okay, creature generation editor node. 2 runtime node. This is one method we want to implement. But I also want to implement, and this one is going to be a little bit messy, I think. We will see. Public list, maybe array. We can probably do it as an array, actually. Generation editor node, get input nodes. BJK, what's up? I'm a little bit tired on YouTube. I don't know why I'm not getting the display names. This time around, why it has changed to the channel ID or whatever it is. I'm having a hard time keeping track of who's who when the name changes all the time, you know? Kevin, yeah, I had a hunch. I didn't dare guess it. But yo, what's up, Kevin? Hope you're having a wonderful Wednesday so far. Okay, so I think this is a beautiful way to do it, because that is pretty much our entire editor to runtime graph conversion. Julius, that's not true. I'm doing my best, I promise. I think this is good. So, and get input nodes. Git amends tutorial is a gem. What are we talking about? GitHub this. Oh, he has a tutorial about Graph Toolkit. I'm gonna check that one out. Thank you. Appreciate it. Git amends tutorial. Let me just put it into my notes. I'm actually getting, I think I'm getting, slowly but surely I'm getting the hang of it. It's not that complicated, actually. It's a little bit bare bones, but yeah, we'll see. So here we want to get the input nodes. We're going to get them as value are the doc comments in XML. Not entirely sure I know what you mean there. Here we go. Class node. Get input ports gives us IEnumerable I port. I port here we can do first connected port. Methods. Try get value. Yes. Okay, I want to get the nodes. Not input port value, get next node. Get output port by name, first connected port. Get node. Get node. What? Am I looking at an old version? 0.4. Just have to see here. Get output port by name. So this one, which returns an I port. First connected port. First connected port. Returns an I port. And then we do get node. Oh, this, I have no idea. It's a sample project by Unity. Yeah, it looks like some sort of XML. Okay, it's nice to know that we have a method called getNode on an I port, but inode. Or no. Or actually, do we have... Okay, let's try this. I want to test it. Let's test some stuff. So generation editor node. Get input nodes. Let's do for each. But I want to get all out. Let's see here. I want to get... Okay, let's take node. I want to get input ports. This is what I want to do. So for each port in get input ports. And then we want to do for each port, we want to get, so here they get first connected port, but I want to get all connected ports. Get connected ports. So we're going to do for each I port as well. Connected port in port.get all connected ports, right? And why VS Code have you changed this again. It's something in this folder. My IDE breaks in the editor folder. I have no idea why. Or for all the files within it. But let's see here. For each port in get input ports, for each connected port in port get all connected ports. And here we want to use get node then. So we're going to do node. I don't know if it's node or inode. It's inode. Inode input node is equal to connected port.get node. And then I just want to do, let's see, inode, what do we have? We have methods, input, output port. Don't we have name or anything? Inode, could we cast it to node? Let's try it. But we don't have anything fun here either. Value, by the way, Microsoft loves their XML. Yeah, at least they did. Where did we have name? Do we have name in ports? Direction display name. I would love to be able to get fuck it. I'm thinking about doing, we do this. I think we're gonna do this. Generation editor node, input node. Let's just try and cast this one. And then I want to debug a little bit. I want to debug. Let's do public string, public abstract string name. Can you do public const? Okay. Okay, we can't even override anything here just yet. Okay, before we test this one, we're going to implement generation editor node for all of these. And we're going to keep it like this for now. So what I want to test is, I pretty much just want to, yeah, if it doesn't contain it here, we're going to get the inputs and print their names. So we should be getting game object to creature node, and then we're going to take the input and hopefully we get set material editor node. If that works, then we can try and print the names of all nodes here. Yeah. Valley, are you making stuff to use in the graphic editor? Yeah, so we're doing like instead of defining our creatures like this to the right here in a scriptable object like this, because our creature is going to be procedurally generated, so this is like a set of rules for how to create them. But setting this up is messy and it looks like shit. It's hard to get a good overview. So I think it's a great example for when a graph interface is much better. So I'm learning Unity Graph Toolkit to be able to translate this to a graph like this. So in the editor, we can set up how the creatures should look like this. And then we also implement a converter, which converts this to a runtime graph. And then we can hopefully generate some nice looking creatures at runtime, which were initially defined by a graph like this. Oh, can't we use... Oh, I'm sorry. We want to use this one here. Yeah, of course. Public override name. And we also want this one to be located here. Same with this one. Values of converting to a runtime graph is a bit like compiling a graph. Roughly speaking, I think it would be. So we basically want to convert it from Unity Graph Toolkit editor.node to some sort of scriptable object. Or actually from... or do we have it? This one. From a Unity Graph Toolkit editor graph to a creature generation runtime graph, which is a scriptable object. Kevin, why don't you use just if node is set mesh node like this? Where are we? Where? Yo, what's up, Krugisa? We're doing a little bit, we're working with the Unity Graph Toolkit over here. Kevin, I think it's better to use class types than strings. Yeah, what do you think I'm gonna use this string for? Like, I want to print stuff. Eventually, what I want to do here is something like this is the only reason I want name currently. Later on, maybe we can alter the graph toolkit with our custom names. Like previous get. Now we're not gonna get the previous nodes by the string. The only thing I want the string for currently is to be able to debug log a couple of stuff or a couple of things. It's pretty much just going to look like this. Exporter, continue here. Yeah, we're going to comment this one out, and then we're going to do... Here we're going to do input editor node dot... Let's see, we're going to do debug.log input editor node name. That's all I want the name for. Krugisa, I've been thinking of getting into the GraphKit for a custom event system I've been developing, but it seems a little bit half-baked. Yeah, it definitely is. Yeah, half-baked, but it's like bare bones currently. I think it's missing a lot of functionality, but you can definitely get some pretty cool graphs working so far. Just use get type toString. Oh, we can definitely do that. That is true. Now we have, like, at that point we can meet. I'm okay with that. But I'm also thinking, like, something I've been wanting to do in Graph Toolkit is change the names here. I want different names here than get type toString names, right? But yeah, let's go with get type toString for now. So we do this instead. Thank you, appreciate it. Yeah, this is much nicer. We're gonna see if it works soon. We have this one in place. Let's see here. And we're gonna do... Nah, we're gonna make it into a list actually. Because we're having 2 for loops, so list might be better. Do I want to do anything here? I don't think so. Okay, we do it like this, because I think it feels a little bit better working with my own custom editor nodes here, as opposed to the other ones. So let's do generation editor node. Okay, like this. And now let's see if we have any compiler errors so far. Oops. iPort get all connected ports. Did I misspell it? Get connected ports. What? Oh. Yo, what's up, Itmost? What theme are you going for? What do you mean? Elaborate and I will do my best to answer. Yo, what's up, Scotch? What is the game called? It has no name currently. Yeah, let's call it. That's not what we want to do. It clears the list before, okay. Okay, let's see if this works instead. Itmost theme of your creatures. I don't know just yet, honestly. We're gonna have some cute ones, some scary ones. I don't know, I haven't found like a common denominator for my creature designs just yet. Scotch Addison, do you have any visuals assets yet? Yes, I do. You can jump over to my YouTube and check out some videos there. Won't be able to pull it up right now on screen. Okay, let's try this. Last thing we want to do is, let's see here. This one we can't do. This one we can't do. This one we can do. This one as well. Yeah, let's do debug. Okay, and we don't add anything new here, and we do the queue. So we're just gonna get the end node. We're just gonna get the end node, and then we're gonna debug it. I also want to check end node here. Like this, I think. Yo, what's up, Spios? Thank you, appreciate it. Have a good one, have a good one. So basically, this test is just gonna go pick the last node, print the name of it, or the type of it. Then we're gonna take its input, hopefully get its input nodes and print the name of them. Given how our graph currently looks, we're just gonna print this type and this type. Why do I have, yeah, not name. There we go. And then get input nodes. Editor node. Yeah, because we're using node here, which sucks. So we're gonna change this one to here, here, and here. Do we have it somewhere else? We're gonna call it generation editor node. Okay. Okay. And here we have it. Game object to creature editor node and editor creature generation graph set material editor nodes. We get all of these. Let's extend this one a bit more then. So we add this and this. So if input editor node, or if this one doesn't contain it, then we add it to unvisited editor nodes. Okay, let's try this then. Hopefully we will get, does not contain a definition for contains. Yeah, of course, contains key. So if we save this one now, we want to get all of these types, starting with this one going backwards. I wonder, and hopefully we will only get each node once. Okay, we get an error. Specified cast is not valid. 23. Oh, is that because of set material editor node? I'm wondering if it has to do with this, that we have no input. But we should have gotten more outputs then, shouldn't we? Can we do... Okay, let's just try this then. If... Okay, I always forget this syntax, so let's see. Connected port get node is generation editor node. Editor node. Can we do it like this? If connected port get node is generation editor node, add it. Yo, what's up, Sam Smite? But we can skip this one. Thank you, Kevin. Okay. Let's try this then. Clear this and let's save. Ooh, we get a few. We get game object to creature editor node, this one. Then we get set material editor node. Then we get set mesh editor node, so this one. Then we get set mesh editor node, so this one. Then we get dynamic mesh to editor node, so this one. Then we get this one. Yeah, that makes sense. Or actually, does it? We never get this one, material instantiator editor node. Maybe I've forgotten to make this one inherit or derived from. We also get this one mentioned twice, but I think that's good. It's an error of mine. Yeah, this debug log, we probably want to put it here. Kevin, so the first node is not the node. What are we talking about? I just need to check this material instantiator editor node. Yes. It's is generation editor node. I wonder why we don't get this one. Oh, maybe I know, actually. I think what we're gonna do is, to make this much clearer to me, I might have been a little bit stupid here. We're gonna remove this, or we're gonna take this one, remove it from here, and we're gonna move it to here. So as soon as we dequeue, we want to take editor node, get type 2 string, and then we'll remove this one as well. Okay, let's try this. Okay, but sometimes my brain not braining. Dude, like most of the time my brain is not braining. Let's save. What do we have? This one, this one, this one, this one. Dynamic mesh to mesh editor node, so this one. And then this one. And then dynamic. And then this one twice. Our instantiation node, so this one and this one, they don't get added. Subs might have terrible brain fog today, so I'm not braining at all. Okay, that's a tad worse, but been there as well. Okay, this one and this one, they don't print. This one prints twice, which is also dangerous. Because I'm missing, let's see here. We never add anything to this one, right? So when we dequeue something here, we want to add it as well. This, we actually want to do it here, and then we want to add it together with the editor node. But for now, we're just going to do add editor node null. Okay, we do it like this. Now, hopefully we shouldn't be getting the last node twice at least. But I'm still very worried. Like, why don't these two print? Generation editor node. Something is wrong here, isn't it? Yeah, I don't think the new ones aren't compiled or something. Now this highlights correctly at least. I really need to fix my VS Code, and now it's actually starting to. Okay, now we're only getting one. That's not good. Am I? Yeah, this one we need to do first. There we go. Take the editor node, check if it already contains. If it is, continue. Otherwise, we add it, log it, add its neighbors to this one. Okay, now let's test. Material instantiator editor node. Okay, so take a look at this. Such an annoying thing. I changed this one, saved it. We even got this little bit of this nice git diff thing. But it didn't highlight it as yellow here. So something was a little bit off. But for some reason, these files weren't included in the recompile. So we had the correct parent type here, but our compiled files didn't. That's just annoying. And another thing, like, yeah, we don't get the correct highlights here. So yeah, something is wrong with... Maybe something with this one. I'm gonna have to figure it out off stream. But okay, now it works. We can traverse the full graph in a very nice manner. So now we just need to implement two runtime node, add it here instead of this one. And then finally... we're gonna have to add children in some way as well. Fuck. Okay. Like, yeah, sure. Currently we can convert everything to runtime nodes and add it to a list or whatever. But we also want to translate the input and outputs. Like, we want to populate these two in our runtime graph. I've done runtime nodes have a port to node index. I've been meaning to check out your implementation on Git. Maybe then port arrow node index would make a little bit more sense to me. But you know what? I think we can populate it. Yeah, we're gonna implement a... I don't know how nice this is, but it's good to have, I guess. Get input nodes. We're gonna have a public... Wait, is this true? Will we always have the output nodes? I think so. Or will... No, actually, no. No, we won't. So if we traverse this one here, we go this, and then we get to this one. We haven't instantiated this one yet. Kevin, like the first output port connects to the fifth node's 0th input port. Oh, yeah, if we build up some indexing. That's true. That's one way to go about it. Yeah, I definitely want to avoid looping through the graph twice. That's stupid. It's editor stuff. This is not done at runtime, so it doesn't really matter. But let's see here. We go this one, this one, this one. No. Okay. We actually do. We go. Okay, yes, I think. Yeah. I know. The way we do it here, I think it's okay if we just take the next. But we're doing this breadth first, I think. We're going this one, this one, this one, this one. Then we're going this one, this one. Oh, fuck, the question is this one. Yeah, we are. So we're going this one, this one, this one, this one, this one, this one. But then we're doing. Let's take a look. This one, this one, this one, this one. Then we do this one, then this one. Then we do this one, then this one, and lastly this one. So we can probably, yeah, we can definitely do, I think we can do, we instantiate this one, we add its previous nodes to our to parse list. And then when we parse this one, or when we're done parsing something, we check output nodes, we get them from the dictionary and add them to the runtime node. I think that wouldn't be too much. So like when we go backwards, let's see. Generation editor node, get output nodes. And it's pretty much exactly this, I think. Whoa. Yeah, input ports, get output ports. Oops, fuck. We want to make this ports. So we could do hell yeah, I think we can do this. Let's see here. Generation runtime node to runtime node. For now, let's add back this one, Let's make it not abstract. Return node. We add runtime node here. I think this looks pretty good, and then we debug it, and then we do for each generation editor node output editor node in editor node dot get output nodes. If I think I want to do this. We're going to check this, the same check. If it doesn't contain it, then something is very wrong. So we're going to do do we have but it should always exist. So what we do then is that we take runtime node dot add output and here we take generation to runtime nodes, and the key is editor node, and we do link is true. So look at this. Isn't this a nice way to do it? So we loop through every node. Yeah, we have an error. But so we take this one, we add its previous nodes to the to parse list. We add its previous nodes to the to parse list, and we add its next nodes as output nodes. So then we go to this one, we add these ones to parse, and this one as an output in the runtime node. Then this one, and we loop through like that. So for each node we check backwards and forwards. If this works, I think it's a pretty nice way to do it. Kevin, in my implementation, every editor node has an abstract interface to turn itself into runtime node. This method should be more cleaner. Yeah, so that's similar to us, right? So we have a to runtime node here, and then each editor node is gonna have to handle it themselves. Because I think the idea is that they should have what information they need easily available. But yeah, we'll see. But I think this should work, shouldn't it? I'm a little bit worried about this one. I guess we'll find out. Failed to get output node. Runtime node in graph. We do it like this. . And that's pretty much it. After all of this, we should have... The question is how we want to store it eventually. I mean, we could basically just take... I'm not entirely sure yet how I want this one to run, how we want to execute this one during runtime. So I'm not entirely sure about the best way to store it later on. So for now, we're just going to store it as a list, basically. So when we're done with all of this, we're just going to take generation to runtime nodes. We're going to pull all the values as a list and store that in a scriptable object. And then we can see if every node is included. Let's serialize this one. Right? Yeah, maybe. Okay. But the last thing... input editor node contains key. Okay, let's see here. Output editor node. Okay. Ooh. Okay. Yes, of course, because we return null here. So we can try this when we have implemented to runtime node here, and then we want to make it into a scriptable object. Right. Kevin using delegate queue, I suppose. Honestly, I have no idea, but we'll see. Okay, let's do runtime to runtime node real quick. So we're going to go back here a bit, and we're going to change this to abstract again. And then we want to implement it everywhere. So set mesh editor node. Set mesh runtime node, set new, set mesh runtime node. I think we're going to change it to... it should be okay. We don't have any options or anything here. We don't have this anymore, I don't think. No, it's the old implementation. Yeah, so everything we need to do here is we just create it. Might as well do this for this one. Set material also. So a lot of these are going to be very basic. Set material editor node. Oh, here it works. So why doesn't it work here? Set mesh editor node. Oh yeah, because we want it to be a runtime node. There we go. Material instantiator. Okay. This one, more interesting. Material instantiator runtime node. We have a private material prefab here. So we want to have a constructor here. Not too sure about the caching here just yet, but public material prefab. It's not really a prefab though, so I'm gonna change it to, is it preset? Or material asset? Okay, like this. That's our runtime creation or constructor. So when we implement this method for this node to runtime node, we want to return material instantiator runtime node. And here we want to add the material, right? And the material we want to add is this one, the one we have here. So it's in an option, which means that we want to get the option material here. Not entirely sure how complicated that is going to be. Hopefully not too complicated. Node method get node option by name. Yeah, we're gonna get node option by name. So that's an inode option. Try get value. Hell yeah. So we're gonna do, it's gonna look like so get node option by name. So it has to be this one, right? I hope. And then we do dot try get value material. That's about it. Although I think we're gonna do try get value as well. Isn't that a, yeah, out t value? So we do this, and then we do if get node option by name, try get value material asset. If this one is successful, then we do this with material asset here. Otherwise, you know what? I think we can do it like this. Instantiate it as null and do it like this. And then we just do material, the constructor here. So if material is equal to, or material asset, yeah, let's crash it if it's null. Okay. So that's the to runtime node for this one. Game object instantiator is going to be pretty much the exact same thing, but we're doing it with game object instead of material. So this one is game object. Game object internal name. Yeah, we want to have a similar constructor here as well. And here we can call it game object prefab. Because here it's actually going to be a prefab. Game object prefab. Get node option by name. Game object internal name. Try get value. Game object prefab. Game object instantiator runtime node prefab. Okay, we have 3 left, but before we continue with those, I'm gonna run AFK real quick. So be right back. Okay, back. Okay, let's fix this error. Oh yeah, of course. We do want to be able to instantiate this one empty as well. And that is true. thought we would have that by default. It feels... Yeah, okay, yep. And then we have dynamic mesh generator editor. Okay, this one is going to be the one with the most complicated to runtime node. Because we have a hell of a lot of options here. But not only that, we have it based on a switch as well, but that's okay, I think. Yeah, I think we can solve this. So we're talking about this node right here. I wonder if it works now when we have some compiler errors. Yes, it does. Okay. So depending on what geometry type we have here, the input varies, right? Very good. And then we also have subdivision rounding here. And in the dynamic mesh generator runtime node, we have setup here. That's all we have, which is a class actually. Yeah, because it was a scriptable object previously. We also need to be able to inherit like this. So yeah. Okay, but we probably want to have a couple of constructors here as well. So we are gonna do... Kevin, just make it to matrix 4x4 when changing it to runtime. So are you talking about the arguments here? I still want it to be pretty clear at runtime. I think this... Can't really see the backsides with having it like this. Can we have a constructor in... Oh yeah, we want int subdivision, float rounding. But actually, I want them at the end. These setups could have like a 2 matrix 4x4 methods. Yeah, I'm just wondering what we would get from that. Or why matrix 4x4 would be the preferable way to store it. Oh, we actually have this one already. Okay, that's good. But then we add this. Kevin, so the compiler knows the size of mesh generator nodes because the size is fixed. Hmm. I'm gonna have to think about that. I'm wondering. Compiler. When you say compiler, are you talking about the actual compiler, or are you talking about our editor graph exporter? Because if we're talking about the actual compiler, or I don't know, like it should be able to know the size of these either way, since they are serializable, right? Right. C# monocompiler. Honestly, I have no idea. That's too low for me. But like all of these are fixed size pretty much. We have a minimum size it can take and I guess this is the maximum it could occupy. Like, we're currently converting our, but all the setups are in different sizes. Yeah, but I'm wondering if you're overthinking it, because okay, what we're currently doing is we are currently converting something from Unity Graph Toolkit.editor.node, so basically a list or some data structure of that type, to some data structure of or to a scriptable object that contains a lot of generation runtime nodes. We still want this to be easily parsable and easy to work with. So when we store it as a scriptable object, a serialized scriptable object, I don't know if it matters that much if it's stored as something like this as opposed to a mat4. But I honestly have no idea. Okay, so what we want to do here is instantiate setup, the correct setup, instantiate node. Instantiating the setup, we're gonna need this one geometry type internal name, and then we're gonna have to do a switch, and then we're gonna fetch a lot of stuff, right? So I think we can just take this. Yo, what's up, Antonino? What's up, what's up? And right now we only have Ico, Cube, and Plane to work with. So I'm just gonna remove all the other ones. Ico, Cube. Is it rectangle we want to go with? Fuck, so it's actually a rectangle. Okay. Default, we're just gonna return so dynamic mesh generator runtime node dot setup. Like this for default. Let's see, Kevin. You have to make a bunch of runtime nodes for every type of meshes. If you use matrices, you only have to make one runtime node. Is that true? I don't know. I don't know. I don't think so. So this is my runtime node, and we just do a switch here on generate, which is basically execute. Antonino, yesterday I picked up a couple of books I bought but never read. They're about cybersecurity. I like to see if they will lead me somewhere. Maybe it's a branch of IT I might be interested in. Oh, interesting. I heard a cybersecurity. I can't remember the name of him, but he said that cybersecurity is it's as interesting and as active of a subject now as it was in the beginning of internet, because right now, thanks to AI, because right now you have a lot of new software coming online where the makers don't really know what's going on, if you know what I mean. So it's a very interesting field right now, according to him, but Yeah, it sounds quite interesting. I've always liked cybersecurity, but I know that if I were working with cybersecurity, I wouldn't be like, it would take a toll on my health, because it would probably be the only thing I can think about. Did I mess up? Did I fuck up? Did I miss doing this? Did I not check for this? I don't think I could ever work with cybersecurity, actually. Doing pen test might be okay, but like implementing cybersecurity stuff, it's insane. I have mad respect for the people that work with it every day. Kevin, that should be good also, my bad. No problem at all, no problem at all. But it's good. I like the input. Sometimes you're gonna be correct with the input. Sometimes I'm gonna be correct. That's just how it goes. Kevin, in my country, telecorporations are not interested in cybersecurity. All mayor, SKT are hacked. Yeah. I think... Fuck, it's such a cool field, but also wild, wild west. It's pretty much the same here in Sweden. I read about breaches every now and then. But okay, so what we need to do now is we just need to fetch a whole lot of information like this. Let's see here. So for a rectangle, we want to get... I wonder if we can do this. So vector 3, Origo. Oh, yeah. Origo internal name. I get value vector 3. But we don't want to get option, we want to get input by name. Fuck, I wonder if we can do this. Let's double check. So previously we did get node input by name. Or previously we did get node option by name. Now we want to do get node input by name. Get node option by name. We're gonna have to do it like this. Get input port by name. Then we get an I port, and then we're gonna have to do, I think we're gonna go with get first connected port. Fucking hell. Can we do try get value? Yeah, maybe. Yeah, I want to do that. Okay, that's actually pretty cool. So let's do get input port by name, and then try get value. Okay. So like this. Get input port by name, Origo internal name. Maybe we should add a port here. And then we try and get the vector. And then we have vector 3 normal. Normal internal name, normal. And finally we have a vector 2 size. something like this. And then we do setup is equal to new dynamic setup, but we want to change it to plain setup. Yeah, the name is a little bit wrong here, but Origo normal size. And then we also want to fetch those two, but those two we can fetch up here actually. But this is probably what we're gonna have to do. Antonino, I'm convinced that many developers don't check their code properly. With AI, everything has been amplified and there are many more vulnerabilities. Yeah, 100%. I think that was his point as well, and why it makes it such an interesting field these days. Because a lot of people just don't read the code AI right, yeah. Kevin, in our case, it's just the passcode. Yeah. Yeah, what is it called? The human negligence. Yeah, human error, pretty much. Antonino, no problem. I know what you meant by IA. In Italian, it is IA. Okay. Yeah. Okay, I get it. But okay, yeah, I also we want to get 2 more values here. Let's remove this now. Gonna do this. I want to change both of these to, now one is going to be int, and the other one is going to be float. So we do int here, float here. This one is going to be called subdivision. This one is going to be called rounding. Rounding, subdivision. And then we take subdivision internal name and rounding internal name. Okay, so we get current geometry type, then we get subdivision and rounding. We also instantiate an empty setup. And then we do a switch case and we get the proper values we want to get. We do setup like this. Okay, what do we have here? Cube, Origo, and size. So we might as well, yeah, let's just grab these. Maybe we could do this as a separate method actually, but we'll see. It is Origo. We don't care about normal. Size this time around is 3. Size internal name. Do we reuse size internal name? Rectangle. Yeah, we do. Could that? It's probably okay. Oops. Here. Okay. Origo size cube, and we change this one then to cube setup. Remove normal, and also we want to change this one should be subdivision and this one should be rounding. And then finally, what do we have here? Origo and float. Okay. Float radius. Something like that. So to runtime node, we take the setup, we do the setup in any way. However we do this, we will end up with something we can use, and then we want to instantiate the node, so then we just do return new dynamic mesh runtime node. And I think it's only setup we need to, yeah, like this. It's gonna be, let's see if we have any compiler errors, or we do the two last nodes. Yep, that's good. When it comes to game object to creature, we're gonna have a lot of settings and inputs here eventually, but for now it's a pretty straightforward node, and so is dynamic mesh to mesh runtime node. So we might as well just do this and this, but we want to change this one to game object Okay, now we have a few more errors, okay? Yes, of course, okay. Out, right? I wonder how that works with... Can we even do it with float, or do we need to do ref? Yeah, probably. So don't we want to do ref here? Can we do it with ref? Let's see. A local variable or function named Origo is already defined in this scope. Oh yeah, we need to do this as well. Is that true? Hopefully. Now we need, okay, so maybe it's not ref, but... Oh, yeah, of course. Are we gonna have to do... We can't define it like this in 3 different places. Later on, we might not have this one, so I'm wondering, should we do... Origo rectangle. But I don't want to do it like this. Okay, yeah, it should be okay to just do this then. Okay, that's the problem with the switch. Can we... Okay, this is still okay. And we have 0 errors now. That's great. Let's see if we can actually make this into a scriptable object then with just a list of stuff. We get an error here. Subdivision was not present in the dictionary. Ordered, or yeah, subdivision and rounding. These are actually option. Great. Okay, no errors. Slowly but surely. Slowly but surely. So we're gonna jump to not editor graph, but runtime graph. And this little bad boy is a scriptable object, serializable by default, right? Or we get serialization by this or from this, I think. What we want to do here is just public list generation runtime node nodes. And then let's add a, yeah, let's make it public. Public creature. Oh yeah, we can't. And let's just set it by scripts. It has both a public set and a get. So in the only step left in scripted importer here, I think, is to just create this one. Create instance. We want to save this as a file. How is it done in the sample project? Where do we have it? Visual Novel Direct Importer. Here we do runtime asset. And then we add it. And then add object to asset. Set main. Ooh. Ooh. Really? Hmm. I wonder if we can see the list if we do this. Let's try it. Um. mm, 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 mm. So after all of this, we want to do this, but we also want to do runtime graph dot nodes is equal to generation to runtime node dot values, just like this, right? Yeah, I can't check what this one returns, but if I recall correctly, we should have dictionary open here, and then we can do to values. Okay, are we gonna have to do values dot to list? Let's see what happens if we have it like this. The name runtime. Did I actually? Okay. Yeah, we call it runtime graph here. Exciting, exciting. Where do we have it here? Asset post processors. Shady graph asset post process. Whoa, 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 whoa. Shady graph. Okay. Yeah, let's see what happens if we save. No errors, that's good. Ooh, if we check it now. Wow, this is very cool. But I wonder if I just need to check close tab. If we open it up here. Oh, we open it as a graph, but here we check it. We look at it as the scriptable object. This is pretty fucking cool. But I don't see my nodes here. Is that because of the bug? No. Why don't we have a list of something here? Generation runtime node. See, oh, yeah, I know. We need to do nodes here. We need, oh fuck, how did we do it here? Okay, maybe I know. We need to search for editor. Okay, fuck it. Let's just open up action handler, animate this one. Abstract selectable editor extension was the word I was looking for. So we want to be able to show abstract classes and their derived subclasses in the editor. So we need to do this. Hopefully it will work. Although, oh, here we have it. Nodes. Exciting, I think. Game object to creature runtime node, set material runtime node, set mesh runtime node, material instantiator runtime node, set mesh runtime node, dynamic mesh to mesh runtime node, game object instantiator runtime node, dynamic mesh to mesh runtime node, and dynamic mesh generator runtime node. Fucking hell, there we have it. Ish. We're not completely done yet, but now we can take it from our editor graph to somewhat of a runtime graph. We could, fucking hell, I think we could probably just run this as well. Because we do know, yeah, we could run it, but it would be unoptimal and we would be doing calculations multiple times for some nodes. But we could just do, we could start with the first node. Actually, do we have any rules when we do, we're gonna have to double check this, but when we do values here, is there some, do we know the rules? Like, is the order for which we get the values defined in some specific way? Is it the same order as we added the elements to the dictionary, or what gives? Because right now it feels like it is, because this order of nodes here goes from this one backwards, breadth first. But I'm gonna have to double check that, because what we could do now, actually, because all our nodes are connected as well, because we have we add outputs here with links, so we could just take the first node, game object to creature runtime node, and we could just generate output. Because then we will call the next node, which is it's some node that can output game object, but in our case it is a set material runtime node here, and then we will try and instantiate the game. So we can just start with the output and go call generate, and then it will go backwards here and finally generate something, but it will call generate on this one twice. Or no, actually it won't, because we have a cache solution here. But then again, this cache solution is not something we want eventually, because we're actually changing the scriptable object. So when we set this value, we're actually changing the scriptable object. Like our runtime graph, we want our runtime graph to be stateless. We're actually going to have so this is our runtime graph, but then we're going to have a creature generation runtime graph executor. And that one will keep cache and stuff like that. So before we actually run this runtime graph, I'm gonna commit first, and then we're gonna start implementing the runtime graph executor. And we're gonna remove, while we're doing that, we're gonna remove the cache or the states on the current state implementation for our runtime graph. And then we can test it. Like best case scenario, I envision a future where we can actually have a window here, a little bit of a preview, which shows how the creature will look, right? So in this case, we would have some dynamic mesh plane. It would pretty much just be a plane with a prototype cell shading material here. That would be very cool, I think. But okay, let's commit this. I think we have implement generation editor node, public abstract class generation editor node. Yeah, make all editor node inherit, and add and implement generation editor node to runtime node. And I also want to add 2 more here. Implement. I love the way, like, I love implementing something and then making a to-do for it. But that's how it goes sometimes. Okay. So far, I think the experience with working with Unity Graph Toolkit has been fucking close to a 10 out of 10. Pretty much no pain. Creature generation graph. Here, that's what it should be called. Add display names to editor nodes. Okay. So we have done all of this on the editor side of things. What did we do here? Yeah, we created this setup. We added some constructors. It's pretty much just only constructors here, isn't it? Runtime graph, yeah. Node system tester. Okay. I want to add, we're going to add the nodes here first. Because that's the commit that adds generation editor node. Then we're going to add commit these because we have added proper constructors to them. And then we're going to add this one. Just very simple first iteration of the creature generation runtime graph. And then finally, we're going to add this one. Okay. We're going to do this one later. Creature generation runtime graph. Yeah. And then we're going to have a creature generation runtime graph executor. Yeah. Yep. Okay. What was it? It was the nodes, right? So let's add these and see what we have. New file generation editor node. Yeah. Add generation editor node related to 209. Okay. And then we have these constructors, and that's the nodes. Is it anything I don't want to add here? I think nodes here as well. Runtime. One, two, three, four, yeah. Add proper constructors to a few or to some generation runtime nodes related to, I think we're going to do 201 and 209 actually for this one. Yes, and then we have this one. Then finally we have this one, right? Pretty fucking great. Do I wanna add this one as well? Yeah, I think I do in this commit. Creature generation editor graph exporter related to 209. Okay, finally, I think we are up to speed. In fact, this one. Oh, did I forget something? Yes, I did. Some meta file, probably. Yes, runtime graph meta. There we go. Okay, so Now I want to implement creature generation runtime graph executor, and yeah, it's pretty much just, it's gonna take a creature generation runtime graph, this one, and execute it. So we want to move stuff like, we have a couple of nodes. I think it's mainly the instantiators and the generators, which currently have a cache. This cache, we want to move it from this runtime node to outside. So the creature generation runtime graph executor is going to keep track of this state. So pretty much it will keep track of if a node has already generated output and some other node wants to access that output. It's gonna make sure that we don't regenerate that output. So in this case, when this one asks for the dynamic mesh from this one, we want to double check, has it already been instantiated? If so, use that instance. If it hasn't, generate it. And I want to do this in a nice way without, I think the sample, it has a set background node and a set background executor. I want to avoid this. I don't want to have more. We already have an editor version of a node and a runtime version of a node. I don't want to add more classes for each node. So if we, best case scenario, we don't. Worst case scenario, we do. So set mesh runtime node executor, set material runtime node executor. I don't think we need that, but we will see. I guess what I'm looking at, let's add a class so we can start experimenting. Runtime nodes, generation runtime node. Generation run, oh, that's not what we want. Creature generation runtime graph executor. What a long fucking name. I'm wondering if I just want to do it. You know what? Maybe. I wonder if we can hide it here. Make it an internal class. Or you know what? We're gonna wait with this executor. I wonder if we can keep it. I wonder if we can have like a public. I'm gonna call it void now. Run. So we have a method here in scriptable, the scriptable object creature generation runtime graph. This method is going to have a state, but the scriptable object will be stateless. So every time we call this one, we build like a state graph and go through this one. Maybe. run. Let's just call it generate. And then of course it's going to return something. Maybe we can do it like this. Creature. Well, you know what? Pretty much like this. So nodes first. Just gonna do it like this. First, generation runtime node dot generate, right? Oh, try get output. This is pretty nice. Do we have access to creature? We should, right? But let's do game.creatures.creature. Okay, it's, yeah. What is the problem? Oh, yeah. Creature. Should I re-implement this one with... I think ref is good. Like this, pretty much. That's what we're gonna do. We're gonna get the first node. Oh, this is so... Like, I love how this looks, and it might just work. But it's gonna fail. Or, like, it's gonna go through the full graph and generate the output we want. But what's gonna happen is that this node is gonna be called twice. And I hate that. But how could we fix it? Like, if we take a look at the dynamic mesh generator, we're gonna call try get output, and it's gonna generate output. And currently here we check if dynamic mesh is null, and we generate it, otherwise we return it. So we have a cache here, but since it's a scriptable object, we can't have it here. So for some, we're gonna have to remove this, but we want to keep this functionality. But I have no idea how. We can't have both that and this, I don't think. Like, I'm scared of, yeah, of course, like, the idea is also to be able to do this on a secondary thread, which means that we might have more than one call of on generate active at once from two separate threads, which means that this one definitely needs to be stateless, and we need to have an internal state in the generate method. So we can't really solve it like this. Which sucks. But it's so nice. We don't even need to have a list here. We only need to have one node, pretty much. You know what? We could inject the state. So in try get output, what if we have a secondary argument, which is the state. How the fuck would that work? Oh, yeah. I know. I wonder how fucked this is, but we could define our state as dictionary generation runtime node. That's the key, and value is, can we do it like this? Nah. But we could do it as object, maybe. That's state. And what I mean by this is that this object here is the already generated output of this node. So when we call generate here, or here, before we do anything, we check the state. Does it already exist in this state? If it does, return that one. Otherwise, this might not be such a stupid idea, actually. Maybe. How crazy. I'm gonna have to ponder this one. Is this insane? I don't think it is, because what we could also do... Oh, okay, this is pretty beautiful. think we're gonna send in the state. This is actually gonna be a custom class eventually, because we also want to send in various random seeds. So this might actually be very good. I think this is a pretty fucking cool solution, actually. So we instantiate a state like this. We're going to instantiate the state based on some input here as well. And then we just go through the runtime graph, injecting this state at every point. Wow. And then we're done. I'm looking forward to like implementing all of these different nodes we're gonna have here. It's gonna be so much fun. But we're gonna start with implementing the nodes that we need to properly add Sten. And yeah, I'm pretty sure this is the route we're gonna take. If it is, we only have one big problem left. And that's basically the idea of having a list. Like nodes might return and get lists of objects as well. So if setMeshEditor gets a list of game objects as input, like we want to implement such that we can, like maybe we want to instantiate 10 game objects here and do all of this for 10 game objects. Okay. But this one is going to be key. Okay. I've got to run now, but I'm extremely happy with the progress today. I think it was great. I love working with Unity Graph Toolkit so far. And no complaints at all. And we're going to continue this tomorrow. So thank you so much for watching, everybody. I appreciate it. And have a great rest of the day. Peace.